Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Ketoenol tautomerism and factors that stabilize the enol form. Moving on to the next step. Identify the three equilibria. X% cyclobutene, its enolate anion, deprotonated enol, i.e., the 2+ charged enolate of cyclobutene with O charge. This represents the ionized enolate form percentage, which reflects enol content under basic conditions. The enolate is stabilized by charge delocalization and the ring system. Y% cyclobutenol with an endocyclic double bond, four-membered ring with C is equal to C inside the ring and O. This is enol tautomer with endocyclic double bond in a four-membered ring. Z% cyclobutenol with an exocyclic arrangement, or on the four-membered ring with the double bond exocyclic or different connectivity. This is the standard enol tautomer. Moving on to the next step. Analyze stabilization. For X, the enolate O form is highly stabilized because the negative charge is delocalized. In cyclobutene systems, the enolate anion is significantly stabilized. The 2+ label suggests a dication or a specific resonance stabilization. The enolate percentage X reflects that under the conditions shown, significant enolate formation occurs. More importantly, cyclobutenyl systems with charge delocalization aromatic like 2 electrons in the anion cyclobutenyl dianion is antiaromatic, but the enolate here may benefit from other stabilization, make X large. For Y, the endocyclic enol of cyclobutene places the C is equal to C inside the four-membered ring alongside the O. Four-membered ring enols with endocyclic double bonds have significant angle strain relief considerations and conjugation with O. For Z, the exocyclic enol, standard cyclobutanol from cyclobutene, is a simpler enol without additional conjugation benefits. And for the final step. Key reasoning for XYZ, X is largest because the enolate anion, O, is much more stabilized than neutral enol forms. The cyclobutenyl anion with 2 electrons in the ring may gain some aromatic stabilization, cyclopropyl analog thinking, or simply the anion is stabilized by the ring and charge delocalization, making X the highest enol-enolate content. YZ because the endocyclic double bond in the four-membered ring enol, cyclobutanol with ring C is equal to C, provides additional conjugation between the C is equal to C and CO, making the enol more stable compared to the simpler exocyclic enol arrangement Z. Z is the smallest because it is the least stabilized enol form. Why other options fail? B. ZYX, incorrect because the enolate, kiss smiley should be most favored, not least. C. YXZ, incorrect because X, enolate, should be greater than Y, neutral enol. D. XZY, incorrect because Y, endocyclic enol with more conjugation, should be greater than Z. Therefore, the correct answer is A. Therefore, the correct answer is option A.